Picture the sun setting over the Bay of Naples, casting a golden glow on ancient ruins, bustling markets, and the vibrant pulse of Italian life. The Phlegraean fields, or Campi Flegrei, stretch out west of Naples, a sprawling volcanic caldera dotted with steaming fumaroles, bubbling mud pools, and serene coastal towns like Pozzuoli. It's a place where history and beauty collide, where Roman temples bear the scars of earthquakes and the ground itself seems to breathe. But beneath this picturesque landscape lies a restless giant, a supervolcano that's been stirring, sending tremors through the earth and fear through the hearts of the 600,000 people living atop it. Scientists are watching closely, their instruments humming with data, as seismic swarms rattle the region and the ground rises at an alarming rate. Is Campi Flegrei waking up? And if it is, what could that mean for the millions in its shadow? Campi Flegrei isn't your typical volcano. It's not a towering cone like Mount Vesuvius, its infamous neighbor that buried Pompeii in 79 AD. Instead, it's a vast, low-lying caldera, a collapsed volcanic crater stretching 12 kilometers across, formed by cataclysmic eruptions tens of thousands of years ago. This is a supervolcano, a term reserved for systems capable of eruptions so massive they can alter global climate. The last time Campi Flegrei erupted, in 1538, it created the Monte Nuovo cinder cone in a matter of days, following years of ground uplift that pushed the coastline outward. Today, the signs are eerily similar: earthquakes, ground swelling, and a growing sense of unease. In 2024 alone, the region recorded 6,740 earthquakes, a sharp escalation from previous years, with swarms like the one on May 20, 2024, when 150 quakes shook the area in just 5 hours. The strongest, a magnitude 4.4, was the most powerful in 4 decades, centered beneath the Solfatara crater, a stark reminder of the volcano's potential. So what's going on under the surface? Is this boiling earth about to erupt? Or is it just the restless stirring of a sleeping giant? Let's dive into the science, the history, and the stakes for the people living in one of the world's most dangerous volcanic regions. Campi Flegrei's story is written in ash and stone. About 39,000 years ago, it unleashed the Campanian ignimbrite eruption, a VEI-7 event that spewed 200 cubic kilometers of magma and blanketed Eastern Europe with ash. Some researchers even link this eruption to the extinction of Neanderthals, its global climatic impact potentially tipping the scales against them. Another massive eruption, the Neapolitan Yellow Tuff, occurred around 15,000 years ago, leaving behind a 40 cubic kilometer legacy. These events carved out the caldera we see today, a sunken bowl of 24 craters and volcanic edifices, many hidden beneath the Bay of Naples. The most recent eruption in 1538 was small by comparison but still dramatic, forming Monte Nuovo after months of intense ground uplift and seismic activity. Since then, Campi Flegrei has been in a state of unrest, characterized by bradyseism, the slow rise and fall of the ground caused by pressure changes in underground magma chambers or hydrothermal systems. The 1982 to 1984 crisis was a wake-up call. The ground in Pozzuoli rose 1.8 meters, 1,300 earthquakes struck monthly, and 40,000 people were evacuated. Yet no eruption followed, and the ground subsided, lulling the region into a false sense of security. Since 2005, however, the caldera has been on the move again. By 2023, the ground had risen 1.17 meters since 2005, with 2/3 of that uplift occurring since 2016. In May 2024, the uplift rate hit 2 centimeters per month, and seismic activity spiked, with swarms becoming more frequent and intense. The question on every scientist's mind is, what's causing this? 2 main theories dominate the debate: the magma model and the hydrothermal model. The magma model suggests that molten rock is rising from a deep magma chamber, perhaps 8 kilometers down, to shallower depths of 3-4 kilometers, stretching the crust and triggering earthquakes. This is supported by studies showing a shallowing deformation source and petrological evidence of magma ascent. A 2023 study in Communications Earth and Environment noted that the crust is weakening, potentially approaching a rupture point that could pave the way for an eruption. However, seismic imaging hasn't found a large magma body near the surface, casting doubt on an imminent lava-driven eruption. The hydrothermal model, backed by a 2025 study in Science Advances, offers a different perspective. It suggests that the unrest is driven by a sealed geothermal reservoir beneath Pozzuoli, where water and vapor build pressure, causing the ground to swell and fracture. This model explains the subsidence that often follows seismic swarms as pressure is released through fluid discharge. Unlike magma-driven unrest, this scenario could lead to phreatic eruptions, explosions of steam, gas, and rock fragments, rather than lava flows. The study proposes managing this pressure by controlling groundwater levels or drilling to release fluids, potentially reducing seismic risks. Both models agree on one thing: the caldera is active and its behavior is changing. The Solfatara crater, a key monitoring site, emits 5,000 tons of CO2 daily, among the highest volcanic fluxes globally, signaling a heating hydrothermal system. Fumarole temperatures and gas compositions are also shifting, offering clues to the subsurface dynamics. The challenge is that calderas like Campi Flegrei are notoriously hard to predict. Unlike conical volcanoes, their vast magma systems produce subtle, ambiguous signals. As volcanologist Christopher Kilburn puts it, studying Campi Flegrei is like diagnosing a disease from symptoms alone without seeing the patient's insides. For the people of Pozzuoli, Naples, and surrounding towns, the unrest is more than a scientific puzzle. It's a daily reality. The 2024 seismic swarms cracked streets, damaged buildings, and sent some residents fleeing to sleep in cars or outdoors. The Italian government has evacuation plans in place, tested in drills like the one in 2025 that simulated moving thousands to safety. These plans assume a 72-hour warning window for an eruption, but some experts argue this may be optimistic, especially if a phreatic blast occurs with little notice. Over 500,000 people live in the red zone, the area at highest risk, and evacuating them could be a logistical nightmare. The Osservatorio Vesuviano, one of the world's oldest volcano observatories, monitors Campi Flegrei around the clock. Seismic sensors, GPS stations, and drones equipped with thermal imaging track every tremor, uplift, and gas emission. Satellite data from the CNR area provides detailed maps of ground deformation, showing how the caldera's center, near Pozzuoli, is rising fastest. In 2024, researchers used high-precision earthquake relocation to map active fault zones, revealing that seismicity is concentrated along pre-existing fractures, some newly identified. These faults could accommodate quakes up to magnitude 5.1, posing a significant seismic hazard even without an eruption. The Italian government is also taking action. In 2023, the Department of Civil Protection prioritized building inspections to identify structural weaknesses, a response to the 4.2 magnitude quake that shook Naples in September. Plans for mass evacuation are being refined, with a focus on moving hospitals and prisons first. Yet the uncertainty lingers. As Carlo Doglioni of the INGV testified in 2023, the best-case scenario is that the unrest subsides as it did in 1984. The worst case? An eruption like 1538, or in the distant future, something far larger. If Campi Flegrei erupts, the outcome depends on its type. A phreatic eruption, driven by hydrothermal pressure, could produce localized explosions, hurling steam, ash, and rock fragments. These are dangerous but confined, unlikely to devastate the entire region. A magmatic eruption like 1538's Monte Nuovo event would involve lava and ash, potentially disrupting towns like Pozzuoli and parts of Naples. The worst-case scenario, a VEI-7 eruption like the Campanian ignimbrite, would be catastrophic, with pyroclastic flows, ash clouds, and global climate impacts. Such an event is unlikely in the near term, as current data shows no massive magma buildup near the surface. Historical eruptions offer clues. The 1538 eruption followed months of uplift and quakes, with the ground rising tens of feet before a crack opened, spewing pumice and fire. Today's uplift and seismicity echo that prelude, but the scale is smaller. The 1982 to 1984 crisis, with its 1.8-meter uplift and intense seismicity, ended without eruption, suggesting the current unrest could fizzle out. Still, the 2023 study by Kilburn and others warns that the crust is weakening, increasing the odds of a rupture that could allow magma or fluids to escape. Despite the fear, there's a glimmer of hope. The 2025 Stanford study suggests that managing groundwater flow or drilling to release pressure could mitigate seismic risks, potentially preventing destructive quakes or phreatic blasts. This isn't a cure-all, but it shifts the narrative from helpless monitoring to active intervention. Scientists are also improving their models, using seismic tomography and geodetic data to map the caldera's plumbing system. These advances could give residents more warning and help authorities prepare. For now, Campi Flegrei remains at a yellow alert level, a 2 on a 4-point scale, indicating heightened unrest, but no imminent eruption. The supervolcano continues to stir beneath one of Italy's most beautiful and populated regions, a reminder that Earth's most powerful forces remain largely beyond our control, but not beyond our understanding. As researchers continue their vigilant watch, the people of Naples and Pozzuoli live with the knowledge that they rest atop one of the world's most closely monitored and potentially dangerous volcanic systems.